My name's Harriet, and I'm here to talk about a very exciting project that we're doing for SAM and QFS. We call it Intelligent Storage for HPC. So Sun's advanced HPC data management products include QFS today as a SAN file system. It has high performance, extremely high performance for streaming I/O. Has a transparent user interface, production ready, very high quality. It is coupled with the Sun Storage Archive Manager, which we call SAM. SAM is policy-based automatic data migration and protection. It has full device streaming, and that's really due to the high performance nature of the QFS file system. It supports tiered storage. Very exciting news for us is we opened SAM and Q. With SAM, it's the first HSM to be opened. We opened this in March. We just did another drop. It's actually in the Mercurial. Our plans are to post SAM and Q 5.0 development code. So we are developing in the open, and we're actually very anxious to build our community. We had already opened LibSAM, which is the interface or APIs to manage SAM. So Shared QFS today has a large existing customer base. It's been shipping since 2002. It's a multi-node file system that targets large enterprises, grid, and HPC. Our clients run on Solaris, that's Spark, x64, x86, and we also support Linux clients, being Red Hat and SUSE. Our metadata server runs on Solaris, but it's Spark and the x64 platforms. We have high availability with Sun Cluster. But one of the most important part of QFS is that it has the built-in HSM. We have, at Sun, the only worm functionality, which is actually being used by quite a number of businesses to support their compliance. Shared QFS currently supports 256 clients, but the project that I'm going to tell you about is we will be supporting thousands of clients. This is our SAN file system today, multiple clients up to 256. We have metadata server and failover metadata servers, but you can see that SAM is fully supported with the robots and tape drives. Shared QFS customer benefits. We have data consolidation with SAN file sharing, multiple node reader-writer access. Here's a quote from HBO. By the way, HBO is coming to you by way of QFS. All of HBO programming, real-time, just play out is QFS. Here's a quote. Provided the scalability to store and manage large files created by program link video with the performance necessary to meet HBO's demanding throughput goals. As you know, QFS was developed actually back in the late 90s for a very classified government customer. This customer is data capture and required very real-time performance. We currently today are holding up that customer, and they achieve 96% of the channel with QFS. And this is 365 days a year. This is not just a benchmark. It provides the performance and scalability. We tune the file system to the application, achieving that near raw I/O performance. It scales linear with the hardware and ramps up as you add hardware. And of course, Shared QFS gives you that parallel processing. And SAM there always to provide that automatic data protection that people so require on their data. Up to 4 copies. So here is Shared QFS certified with Sun Cluster. We are very much positioned in quite a number of sites with Oracle RAC. We, of course, have the high availability with standalone QFS, with the HA NFS, but really, our Oracle RAC sites are very, very exciting. It runs on shared QFS and has Sun Cluster for high availability. Oracle has actually certified 9i, 10G, and just recently 11G. The shared QFS license is free for this configuration. And the really, really exciting thing, QFS is really known for streaming I/O, very high performance, like I said, near raw performance. However, on our Oracle RAC, we are achieving transactional performance that matches raw also. Now, I've talked about SAM. SAM is the Storage and Archive Manager, and this is providing the data protection. Your file system is not a scratch file system. It is fully protected with SAM. Our media can be disk, tape, or optical. We support local and remote copies, and our classification to group the data is very strong. You can group that data with path, owner, group, size, wildcard, and last access. Our media format is TAR, and this is an open format. It was the best decision we ever made to write in an open format. There's no vendor lock-in here. But one of the other fallouts that's very good about TAR is SAM is extremely good for small files because we're containerizing those small files into a large TAR file so that we can stream those tapes. The last thing you want to do is stop a tape. We keep all data available, but not on high-cost storage. So that data moves across those tiers of storage according to access. We have on-demand transparent file retrieval, and most important, we're continuously backing up your data, continuously protecting your data, and this has no the application doesn't have to do anything. This is completely automatic. For our policy-based SAM processes, we transparently archive from the disk cache with time-based archiving. We manage the disk cache with a high and low threshold and keep that based on policies. And we automatically stage that data back from the media on access, although we have options to pre-stage. And we have options to bypass the disk cache and go directly to the application buffer. And of course, we're recycling our media by repacking it. Now, you heard a little bit from Peter Bojanic about the data mover. We are at TAC, we're at ARCS, we're at KISTI. This is using SAM as a long-time retention and archive with a data mover where the data is, we actually install our Linux client on a Lustre Linux client, and we access the data directly without going over a network. And this gives very high performance. Chris Wood will be talking more about this architecture. In the TAC, we have 5 StorageTek 8500s. This is the large robot, 48 of the T10K disk tape drives, and the StorageTek 6540 RAIDs. Most important about SAM is our archives are open. Our media format is not proprietary. So your files can be recovered from those archives written by SAM, even without SAM, because you can read them. The most important thing about an HSM is the metadata about the data is also on the archives. If you should happen to lose your metadata dumps, you can still recover your data. Okay, now I'm going to go past this and talk a little bit about how we're horizontally scaling SAM QFS for HPC. We are going to be supporting object-based storage. This is moving our allocation to our storage node. Some of the other features under development that I'll just go briefly on are metadata journaling, SAM performance. We're supporting a sideband MySQL database for fast queries for SAM data. We'll be supporting rolling upgrades, online grow and shrink, and some of the other features here. But I want to really jump into our scalability project. And this is called intelligent storage. we are enhancing QFS to support intelligent storage. With our intelligent storage support, we will move into thousands of clients. We're targeting Sun's Commodity JBOD storage, but it also works with enterprise RAID storage. We will continue to support our QFS SAN block-based file system along with our object-based file system. We'll support both of those two types of file systems, and most important is SAN will be supported on both of those file systems. Our space allocation is done in parallel in the storage, and this allows our bandwidth to scale up. That knowledge of the data is pushed out to the OSD devices so we can do better resource utilization, pre-fetching, and also giving quality of service. Our current roadmap is to include releasing shared QFS with object-based storage end of this year in an open Solaris HPC distro. So some of those features that will be there in, of course, our metadata caching is full supported on the client, so our metadata ops, we've measured over 185,000. This includes opens, removes stats. Our storage, we support storage pools to group like storage. Storage pool is completely selectable. You can have fiber channel disk and SATA disk in two different pools, and we'll stripe around only liked storage. You can set the depth and the width. We support paged and direct I/O in our clients. And of course, we support ACLs, clients, quotas, FLOCs, failover. We really are a POSIX parallel file system with built-in archive. With this project, we're supporting RDMA for InfiniBand, so we'll be supporting ICER initiator and target, and this will give us the speed that we require for this cluster. This is a picture of our scalable QFS using OSD-based storage. Our clients, our metadata server, SAM fully supported, writing over a high-speed InfiniBand network to our object-based storage. We will be running QFS in the clients and on the object storage. Here's the ICER over InfiniBand, which gives us our RDMA support, 0 copy. So we're bypassing all of that iSCSI stack. We are standard. We still have the iSCSI manageability, but we know a lot of that overhead that comes along with iSCSI with our RDMA ICER project. So here's the components of our project. We have shared QFS enhanced to support the ANSI standard OSD protocol. We have a new file system type. We have a new device driver. And we have iSCSI enhanced for ICER DMA. This is on the initiator side. On the target side, we have iSCSI target enhanced for the ICER RDMA. We have a common multi-protocol SCSI target called ComStar, a T10 OSD LUN provider, and then most important, we have object QFS file system, allocators only, no namespace, and as a new file system type, which gives us our speed. Our Open Solaris projects, all of these projects are being developed in the open, everyone on that previous page, and here's a list of the websites. Future, looking out, PNFS is very important for Sun, is to support the PNFS with the object layout, which can talk directly to our object-based targets. I want to end here by saying you're all welcome. We're having a BOF on Wednesday, June 18th from 3 to 4, and we'd like you to come. Feel free to ask a lot of questions and deep dive on a lot of the stuff that we're doing. Thank you.
Thank you, Harriet. Any questions for Harriet? No, I guess you're all